So now we will try to sketch the graph of a polynomial using things that we know and things that we've just talked about. So one of the things that we can do in order to sketch the graph, we've got a cubic function here, highest degree is 3, is first think about the intercepts. So if we think about the y-intercept, that is simply finding out what happens when you do f of 0. And if we do that, we get 0 cubed plus 0 squared minus 6 times 0, and oh wow, we have 0. So we're going to have the point 0, 0. Now, typically the x-intercepts can be more challenging because you're taking the polynomial and you're setting it equal to 0. So that's what I have right now, as you can see. I'm always going to try to see if I can factor. This is a cubic function. We'll talk more about how else we could find the values, but for now it's going to work to factor. So I'm going to do the greatest common factor here, and then if you want, you can pause, see if you can find the rest of the factoring real quick. So we have x, x. We either have 1 and 6 or 2 and 3, but we want that difference to be positive 1. So it's going to need to be the 2 and the 3 with a plus and a minus. And that's going to give us that x is 0, 2, and negative 3. So realize that that gives us the point 0, 0, which we already knew because that's the y-intercept. It gives us the point 2, 0. It gives us the point negative 3, 0. Now, if you want, one thing that you can do, because it's all on one piece of paper for you, is that you could put those points on your graph now so that you have them. So you have the 0, 0, you have the 2, 0, and you have the 3, 0. Excuse me, it's a negative 3, 0. Let's take that back a notch. But this helps us because we know that it's smooth and continuous, so it's just going to, go up and down around these x-intercepts here. So one thing that you can do is think about the idea of a sign chart, and that's what we have here. And the things that we want to include on our sign chart are those x-intercepts. We want to think about what's happening to the function as x heads towards negative infinity or as x heads towards infinity. So I'll have negative infinity, infinity on either end. And then I'll put in my intercepts. So I'm going to do them in order, smallest to largest. So negative 3, 0, 0, 0, and 2, 0. So notice this is x and f of x here. And so it's just kind of thinking about what's happening. And then what I'm going to put in those blank spaces in between is just, is my function positive or negative? Literally, are the y values positive or negative? Because the only place that they can change is during an x-intercept. Then they could go from being positive to negative, and that's why the sign chart helps me, because it tells me what's happening in between. So what I'll do up here is I'm just going to put the factored form here so that we have it right next to the original. And so this is all that I'm saying, is that we can think about first, let's think what happens when we put in a negative infinity into this. What I've already mentioned is when you're thinking about what happens as x goes to negative infinity, you don't have to even think about x squared or minus 6x. They do not matter. The only thing that matters for end behavior is what degree it is, which is cubed. So we know it goes like this or like this. And the fact that the value in the front of the x cubed is a is 1, positive 1. So that tells us that when x gets really big, y gets really big, positively. And when x gets large negatively, so x heads towards negative infinity, y is going to do the same thing. It's going to head towards negative infinity. So our function is going to do this. And that's just one of the 4 options that we've talked about previously. So we'll have a negative infinity here, and we'll have a positive infinity here. So my point is, well, I won't draw anything else yet, but that's my point. Okay, so, and I can write that on my next sheet. Okay, so let's just write that here, and then I'll come back. So the leading term is x cubed, so n is 3, that's odd. and a equals 1, that's positive. So those are the two things that we need. So that tells us that as x goes to infinity, y is going to do the same thing. And it also tells us as x goes to negative infinity, y is going to go to negative infinity. And that actually tells us something about our function already, because it tells us that we must head towards negative infinity as x is going towards negative infinity, and we must head to positive infinity as x heads towards positive infinity. So we actually already have this idea of what our graph looks like, and we just need to fill in that little middle part. And like I said, that's pretty simple, because if we just pick values, so the first thing I'm going to do is pick a value between negative infinity and negative 3. And I can literally pick anything. So I could pick some sort of test point, x equals, say, negative 10, really doesn't matter. And then I'm just putting that back into the original. I do not care what the y value is. All I care is it positive or negative? So hopefully you can follow along with me. If I do f of negative 10, I'm going to have negative 10 times negative 12 times negative 7. So that's going to give me a negative times a negative times a negative, which, as we know, is a negative. So we end up with that. Now that is not surprising, because we've already drawn it. As you can see, we are already, from negative infinity up to negative 3, we are already having negative y values. So we actually already have that. Ooh. Now, between negative 3 and 0, I could pick something like x equals negative 1. We plug it in, so we're finding f of negative 1. F of negative 1 is going to be a negative 1 times a negative 3 times a positive 2. Negative, negative, positive. That's going to be positive. So what that tells me is that my y values from negative 3 to 0 need to be positive. So see, I'm going to go up. And my point is, I can't go like this. I can't cross the x-axis again, because those are my x-intercepts. So I just have to go from one point to the next. That's all I can do. Now, I don't know if it goes like this or if it goes like this. If you want to find a few points and find out the actual height, that's fine. But this is a sketch, so you don't actually have to worry about that so much. All you need to do is just get it from one point to the other. Now, you probably know what, you think you know what it's going to do, but we can pick a point. For example, let's test x equal 1. I'm going to put that in, so it's a value between 0 and 2. Why not 1? And it looks like I'll get 1 times negative 1 times a positive 4. So I have 1 times negative 1 times positive 4. So that's going to be a positive times a negative times a positive, which is a negative. And again, we're not surprised by that, because it does look like it's not surprising that it would go down and come back up and look like this. And then we can already see, because we've already thought about the end behavior, that we know that if we were to pick a value between, so we pick, say, x equals 10, we plug it in, f of 10 is going to be 10 times 8 times 13, positive, 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 everything is positive, and yes, our y values are positive, and we can already see that right here. So this is a sketch of what that polynomial looks like using the things that we already know, plus some stuff that we've just talked about. Okay, now you'll have a little factoid here, which is if you have a polynomial of some degree, and that degree is n, then you will have at most n minus 1 local extrema. Now, if you're like, what is that? That is just maximums or minimums. You can't have more than n minus 1 local extrema. So in this case, this is our example. Degree is 3, it's the highest degree. And what this note tells us is that we will have at most 3 minus 1 or 2 extrema, maxes or mins. And you can see very easily from our picture here, that's what's great about it, is we have one max, we have a max right here, and we have a minimum right here. So we do have 2. Now we could have had 1, we could have had 1, we could have had none, but it's at most n minus 1, at most n minus 1. So we couldn't have had more than 2 of the extrema, and in our case we actually did have 2, a max and a min. So we're going to do one more here. This one's slightly different because it's actually already factored for us, which is nice. I don't know if you see that or not, but it is already factored. And so when we think about this one, like the factored form is like nice, except we might want to be thinking about the leading term. And it can be hard to see the leading term because it's in its factored form. So the thing to think about this is all you have to think about is these first terms and what would happen if you multiplied them together. So you should think, okay, my leading term would be an x times a 2x times, and then notice that you have x plus 1 squared. So it would be, what would be the first term if that were multiplied out? And if that were multiplied out, you'd have x squared plus 2x plus 1. That's what x plus 1 squared is. So that leading term would be an x squared. Okay, so the leading term here, if you were to multiply this all out, is 2x to the 4th. And that's all we need. That's going to tell us something about the shape of our polynomial, specifically the end behavior of it. We can start out, now that we have that, we'll use that in a minute. But what we have now is we need to find f of 0. So notice you're going to have 0 times negative 3 times 1 squared. Doesn't matter, it's still 0. So there we are. X-intercepts, notice that's why the factoring is so nice, because in being already in its factored form, we're going to have the fact that either x equals 0, 2x minus 3 equals 0, or x plus 1 squared equals 0. Well, one of those is already there. We already knew that, 0, 0. We can solve this one for x. So we also get 3/2, 0 as another x-intercept. And we also have, if we square root both sides and subtract 1, we also get the point -1, 0. So here are our 3, count them, 3 x-intercepts. So I'll put those onto my graph. 0, 0. I've got, what did I just say? -1, 0. There. And 3/2, which is 1.5, 0. So here's my 3 x-intercepts. So those are going to go onto my sign chart, as well as the -infinity and +infinity. And then I put my intercepts on in order. So -1, 0, 3/2, 0, 0, 0. Okay, now we're just looking at what's the y values. Are they positive or negative between any of those things? That'll tell us whether we're above or below the x-axis. So we can think about end behavior. As x goes to -infinity, we want to think about that leading term. Well, it's to the power of 4. That's an even power. And with 2 being a positive number, you can think if you were to plug -100 in there, you raise it to the 4th power, that's a positive number, times 2 is positive. So as we choose large negative numbers, we're still going to come out with positive y values. And of course, those are going to get larger and larger and larger because you're raising something to the 4th power. Similarly, trying to think about where I'm going to put my face in this, my video face. Ooh, we'll see. Okay, so as x goes to +infinity, you can see that you put in large values, you put in 100, you put in 1,000, you raise it to the 4th power, it's huge, positive, you multiply it by 2, it's just even bigger, but it's positive, and so we're going to head out to infinity as well. Wow, that is one ugly infinity. So, there we go. Okay, so I think I'm just holding my tablet funny here, or my pen on my tablet funny, because it seems to be creating that. So if you want, you can add that to the graph that we're working on. You can add it to the graph. That's going to be handy. And you'll see that you're on your way. There we go. It's a little bit better. Okay, so coming over here, we're finding out, because we have this even polynomial, even degree polynomial with a positive coefficient, that we're going to head out towards infinity up here. We're going to head infinity up here. Ooh, there we go. Okay. All right, so now we're going to test some points. So we're going to have x equals, I don't know why, but I like that -10. Okay, so what I want you to see, what can actually be helpful to you is, we're always trying to, you might not believe it, but we do want to make our lives easier if we can, in whatever. So if we think about this term right here, I want you to notice that it's squared. So you have x plus 1 squared. No matter what value you put in, that's always going to be positive. So really, you only have to think about x and 2x minus 3. Because it's going to be something times positive, every single value you put in. That's handy. So we put in -10, and we find f of -10, and that's going to give us a -10 times a -23. Negative times negative is positive, and then we know it's times positive. I don't even have to do anything. It's positive. So we end up with positive. Now, we already kind of knew this because we already knew that we needed to head up towards positive infinity. So yeah, between when x is some large negative thing all the way up to -1, we're going to have positive values, because that's the only way that it is going to head out to infinity. Now, between -1 and 0, we might have to get a little bit creative here. I'm going to have to use a fraction. But again, you don't even have to spend a lot of time if you don't want evaluating. You're really just saying, is it positive or negative? So we are going to have a -1/2 times a -4, negative, times what we know is going to be positive. Negative, positive, positive. So we're also going to be positive between -1 and 0. So that means I have to do something like this. I have to go up and come back down, because I have to go through those two intercepts, and my y values have to be positive. It's the only thing that can happen. Here's a tip. There is a reason why the sign is the same on either side of -1. And if you remember this, it'll be very helpful to you in the future. It is all because of that 2 that you see on the factor of x plus 1. That is the reason. I don't know if this is going to make people too much writing here, but it's that negative on either side of -1. The sign is not going to change. I'm not saying it has to be positive. I'm going to say it's not going to change because of the fact that it comes from a factor that is squared. So that means on either side of -1, you're not going to have a sign change. I want you to notice that this 0, the next one that we're going to be thinking about, comes from this factor right here, and this factor has a power of 1. So if I choose something like x equals 1, I'm going to have 1 times -1 times something positive. And that's going to be negative. Notice the sign changes on either side of 0. Now, the 3/2 that we have here is coming from this factor, which is also to the power of 1. So now I can choose anything. I'm going to choose x equals 10. And when I put that in, I'm going to have 10 times 17, positive, times a positive, I'm going to have positive. I want you to notice again, the sign has now changed again. The sign is going to change on any factor that has a degree of 1, so the root that's coming from there, the intercept that's coming from there. For a factor that has a multiplicity of an even number, we'll talk about multiplicity, but just an even number of the factor, the degree, the sign is going to stay the same. So now let's take a look at what that looks like. So we're going to head to negative values. I don't know how far it goes down. I'm just going to have it go down and come back up. If you want to find true y values, you can. It's just a sketch. And then as we already knew, because we already looked at the end behavior, we're going to head all the way up to, infinity. So we've got positive y values after 2. And here's a sketch of this polynomial. So it's a few steps, but with all these pieces, you can get a pretty good idea of what the polynomials look like. And that's section 3.2.